Thank you very much for coming to this talk in such a late afternoon. We really appreciate. I'm very happy to see these many people. I was hoping I was thinking it's going to be less, but thank you very much for giving your time to this talk. What we're going to share today is our journey in creating, if you are part of you can relate to this problem. If let's say somebody is asking you, hey, I need an ELK cluster. ELK is Elasticsearch Log Stash Kibana, or I need a database, right? How can you automate the whole provisioning of ELK cluster or a database and give it as a service to your developers? Then you can relate to this talk, right? This is what we are doing. I need a new stack, and how can you automate the whole thing using Chef tooling? This talk is for you if you have those kind of problems. Also, we will share our experience, when we built this stateful software as a service runtime using Chef and Habitat, what were our learnings in last 2 years? What worked well for us, what didn't work well for us? This talk is for you. So my hope is that we learn few things the hard way, the really hard way, the painful way, and I hope you get some takeaways from this talk and be prepared if that hard times come in your life, right? So again, thank you. My name is Amulya. I work for GE Digital. To begin with, I have a question. How many of you have Chef in production? Amazing. How many of you have Habitat in some capacity, not in production, but tried it, used it, know what it is? Okay, perfect. Yes, this is for you. So in this talk, you will also get a use case, if you already have Chef, where you can introduce Habitat, what it can do for you. So that's another thing which you can learn. So this is good. Right? So let's get right into it. At GE Digital, our mission is to create the industrial cloud which can, which industrial companies can use. And so we have an offering called Predix. Predix is an industrial cloud. And 3 simple steps, if I can explain what Predix is basically ingest, store, and analyze. When I say ingest, mean ingest the data from the edge, which can be a wind farm, which can be a gas turbine, which can be a jet engine. When I say store, bring it to the cloud, not all of it, but at least some of it, or most of it, and store it into the big data stores in the cloud. And analyze, meaning then run analytics like AI, ML, or even simple analytics like a time-based chart, how my asset is doing over time. Simple analytics on it. So that's our ingest, store, analyze is our mantra. So this is simply the Predix cloud is all about. Why it is important? The reason why it is important to do today is I give you this 1% idea which I really liked. So this 1% is if we can understand how the machine is operating in the field well, and if we can improve the machine by 1%, then the savings are a lot, right? Because in this case, if we can improve the fuel saving by 1%, hundreds of millions of dollars will be saved a year. Same thing in power generation. If we can increase the power at 1% more efficiently, the savings is going to be huge. The amount of power we're going to generate is going to be huge. And similar stories with the healthcare. 1% efficiency in reading and making the machine work well can save more lives. So even if you can gain little bit more advantage, the implication is huge and very beneficial. So to give you the scale of our cloud, it is a pretty big scale. We have tens of thousands of machines. We have tens of thousands of developers developing on our cloud. We have almost 50,000 plus applications running in one POP, and we have 5 different POPs. And this is 4 different geolocations our cloud is available. And we have thousands of software stack. When I say software stack, this is ELK as a service, this is Redis as a service, database as a service, message queue as a service, and so on. I'll talk more about that. To give you a little bit detail of our cloud, it runs on different IaaS providers. So our cloud, we run it on Amazon, Azure, and on-prem. We have an on-prem offering as well, which runs on vSphere. It is primarily built on open source technologies like Cloud Foundry, Kubernetes, and virtual machines. So to place the workload, it's basically it's going to get placed either on Cloud Foundry, Kubernetes, or virtual machines and storage with it. We run stateless applications, whichever developers write, like the developers who are on the platform, and we also provide them stateful services like database as a service, message queue as a service, and then the cache as a service. The way we approach our stateful services is pretty simple, and this is our use case. Our use case is there should be a simple API, right? There should be a simple API to create a service, and the API model which we adapted so far from the beginning is an open service broker API. I'm not sure if you guys are familiar, but there is an open service broker API concept which is gaining a lot of traction for service providers. Let's say if you provide software as a service, then a lot of people are adapting this open service broker API interface. It is not like, it is just the interface which defines like what you should implement, and the benefit you will get it is like if you use something like Cloud Foundry or Kubernetes, your service will, you can automatically register your service in the catalog because catalog looks for this open service broker API. So there is this API where you can create a service or delete the service if you no longer want it, and update and figure out what's going on with the service. Behind the scene, we takes care of all the infrastructure creation, service configuration, up and running, backup, restore, everything we takes care of it. So for the developer, it's just the API. Hey, can you give me a Redis? I don't know how, but give me a Redis. This is how it works, right? And as I said, it works on all Amazon, Azure, and on-prem with vSphere. So this was our use case. Now I will go into the detail how we implemented this use case. So when we started, and we were like big on Chef at that time, right? Like we were like still big on Chef. So when we started, so we created this APIs which implement open service broker API interface. So the first thing in the step is like create the machines, right? So for creating the machines, and we wanted to run on 3 different clouds like Amazon, Azure, and vSphere. So we used Chef provisioning because Chef provisioning has driver for all 3 of these, right? So we use Chef provisioning to create the virtual machines. So machines and storage get provisioned using Chef provisioning. And then on the machines which Chef provisioning creates, we run Chef cookbooks for that software. Like if it is Redis, we run Redis cookbook. If it is Elasticsearch, we run Elasticsearch. And if it is like so on. And we'll go into the detail in the next slide. So the way it works step by step is the Chef provisioning cookbook, as soon as the create request come, it gets into the queue, and then there is a Chef client runs, which runs the Chef provisioning cookbook, and in that cookbook it says like how many nodes I need to create. In the workload there is like defined how many nodes I need to create. So based on the cloud which it runs, it's create with that driver, the load balancer on all the machines. Then service cookbook comes into the play, and then on those nodes, the Elasticsearch, in this case, it is an ELK cluster. On those nodes, depending on the node type it puts that cookbook on it and converges the node. And then to make a cluster of Elasticsearch, because in the cluster, one node needs to know about other nodes, right? What are my peers? We use Chef node search, and with that node search, we find the IPs of the peers and reconfigure the cluster and restart the service. And to keep it up and running, we use Chef client. Chef client is always every 30 minutes keep converging on those machines. So that's how it's like step by step works. Now, when we put this together, right, when we put all of this together, there are few things which worked well for us and the few things which did not go work well for us. Like it's hard, and I'll go into that now. What worked well is like, because we were using Chef, whatever the software we needed, there was a cookbook for it. The community is pretty awesome, right? Like you want Redis, there's a Redis, very well maintained cookbook, right? Like people are maintaining them very diligently. The other advantage was end-to-end tooling was available, right? So if you want to do local development, there was Kitchen, Burgs, Inspect, Knife, all this tooling was available, right? When you put this kind of complex system end-to-end, sometimes you need fine-grained orchestration control. Like for example, I do not want to converge my nodes until all the nodes are available in Chef server, because then the node search will going to give different results. So these are like, when you implement something like this, you'll go into some of these problems where you need a fine-grained control. And the orchestration control with chef provisioning and chefs together was fine-grained enough that we were able to achieve whatever we want to achieve. And the last is one tool set for all of our problems. Basically, we didn't use any database to persist this store. We used data bags, right? We didn't use HashiCorp Vault or something. We use Chef Vault, encrypted data bags. So everything what we needed to make the system work was available in Chef server. So that's the good part of it. But as I said, few things worked well, few things didn't work well. So what was hard with this system? So one of the hardest thing is dependency management. When this convergence happens, right, the way, and you guys are like pro chef here, right, you know the compiled cookbook list is sometimes if you do a lot of things, it's crazy. And most of the time you don't have everything in the local repos, so it downloads from internet, it compiles, and one guy is using app 5.0, other guy is using app 6.0, and it all fails. And it doesn't even tell you where it's failing. You have to like go and figure it out yourself, right? So that was one of the hardest things, cookbook version mismatch and the gem, and we still have these problems, right? So the other hard part was the upgrade. There was no way to upgrade a cluster. So basically, if there is a cluster of 3 Elasticsearch node, and you make a change in the cookbook, and you pin your environment to the new cookbook version, the upgrade can happen in any time in next 30 minutes. And it can go to the all 3 nodes together because chef client is running. So there is no way you can orchestrate that, okay, the first node should upgrade, then second node should upgrade, then third. There's no way. Unless you do the crazy things in your cookbook logic, right? You write that crazy stuff. So that was another problem. Like there's no controlled way to do a rolling upgrade kind of thing. Few other problems, service discovery. The only way to find other nodes was using node search, chef node search. That's the only way you can find the IP of the other nodes. Leader election, if you have advanced use cases like one guy has to be leader and distributed, then that is a hard problem. Chef treat all the nodes equally. And the IaaS provisioning, like all 3 different IaaS we run on, Azure, Amazon, and vSphere, the driver is different, and there is some differences in the driver. So these are the hard part. So at this time, I would like to call Deepak to go over how we solve some of these hard problems.
After this one version, like, when Habitat was launched, I asked myself a question that, is it going to replace the whole thing which we have done, or will it work like independently, or is there a collaboration like, Hab and Chef can work together, right? So as we saw the earlier version, this is the version 2.0 when we bring in the Hab in our framework. So what changed here is that the provisioning of the resources, the provisioning of the VM and the disk is still the same way. But we figured that the problem which we discussed about dependency management and all other stuff, we can really take, Habitat over there and we'll have a simplified version of it. So in the same workflow, so this is exactly same, all the resource provisioning happening the old way. But next thing, when I need a package, I need a service, a software on a machine, I'm not running a chef cookbook which will go and install the system. I will push the Hab, which is still happening using chef because somebody need to ship your Hab supervisor on the machine. So we ship the Hab and then we just specify, we drop a file, the spec file, which has all the configuration which needs to be there on the system, and we leave it to the Hab, and then it's Habitat supervisor's job to download all the packages, and then if there is any integration, wait for them. So that's the next part, service discovery. Instead of doing a node search on the chef, again, we don't do anything. We just specified at one time that, Elasticsearch, Kibana, you need to wait for Elasticsearch. You have to integrate. Logstash, you have to integrate with Elasticsearch. And we tell this to Hab. And no matter in what order the node comes up and the Habitat starts, but the Habitat will make sure that I will not start running Kibana until I have the Elasticsearch available in my ring. So that was really easy, like it's an inbuilt feature. And the final thing that I need to make sure that my cluster is at the desired state all the time. I stop running chef client again and again, and Habitat is doing that because Habitat is already running, the supervisor is already running as a service on your machine, and if anything happens to Kibana or any other software, it will detect it and will restart the package. So you have the availability. So this is what changed with the habitat. So what is working well for us if we compare with the problems we discussed, like dependency, right? So just for example, like if I am running a Redis cookbook, I'm trying to install a Redis, and what I'm doing, I'm compiling the Redis on the machine at the runtime. It might happen sometime due to some network issues or some dependency issues that Redis didn't compile, it failed, right? But using the packaging system of Habitat, I remove that dependency from the runtime and I go back to the development time. So I'm writing my package right now and I build it and I make sure that everything is working successfully. I build the package and I ship it. Now, when it goes to the runtime, it doesn't need to do anything else. It just pull that package, put it on your disk and just start it. So the packaging, the hard packaging is working really well. Service discovery and leader election. So service discovery we discussed. I need to wait for other. The leader election was the other thing that now let's say I'm running a 3-node Redis cluster. Now there has to be one who is a master and others are slave. Now in the old fashion, I'll just write a random algorithm that, okay, I have 3 divided by 2 plus 1, whatever, I give a name and I figure out, okay, you are the leader. Then what happens? The leader died. Okay, I need to find another leader. Okay, who are available? Promote a slave to a leader. That comes again inbuilt with the habitat. So we define a topology. We say it is going to be running into a leader topology, and then supervisor will do the election. It will make sure there are at least 3 nodes. It will detect a master. If that goes down, it will promote a slave to the master. So that is really working well. It's deterministic because everything is packaged. There is no runtime surprise. We know what we ship. That's going to be land on the machine. Faster convergence. So as the earlier in the chef cookbook configuration world, we were like building a lot of packages on the machine. It takes a lot of time, but now we moved that time from the runtime to the development, so it's faster. At the time of creation, all happens is download the package and start it. No building, no source building and all that stuff. So it's faster. Rolling upgrades, again, it comes out of the box from the habitat. We just define what kind of strategy we want to use for the upgrades, and it follows that. So we say, yes, we want to go with the rolling. And nobody wants that, your system, your application goes down just even for a second or 2 seconds, just because you are doing some upgrade. So the rolling upgrade, the habitat supervisor will make sure that when you ship a new change, it will go to one node, update, and slowly progress. So at least overall your application is always available. So these are like out of the box inbuilt feature from the habitat which are really working for this particular framework. Now, what we are seeing now is that when we talk about this, most of the people ask, okay, wait, like what is habitat? Like that's the state is happening. But I mean, yeah, the community will grow, everybody will, ramp up on the habitat and we'll have more support and everything. But apart from that, as we discussed, that we changed one layer, which was how my software is, configured on the system and how it integrates to habitat. But we had one more part, which was how do I get the resources up and running? How do I get the VM? How do I attach the disk to that VM, right? That's still there. So as we're using the chef provisioning, there are a lot of drivers, as Amulya told, there are so many IS providers which are being used here. So there are so many code paths for each and every different driver, and we have some specific requirements, so there are like changes, so we have to like keep the local code version of the driver. So it's getting it's increasing, the code is increasing every day. Expensive, it's expensive from the time perspective because the VM creation, at least it might take somewhere from 1 to 2 minutes, 2.5 minutes, something like that. And then everything is a VM, so there is a user space, then there is an application space, so there is a resource overload. We definitely end up spending more resources than we really need. So that's the expense part. And then when we talk about this, and we talk about expensive and timing and everything, people ask, where is Docker? Why not Docker? Everybody is like Docker, right? So at the time when we started running this particular thing, definitely the state, and we are talking about a stateful services, we are talking about a disk, data going to the disk, right? At the time, there was not a solid solution available where we can say that yes, container is running and the state is also working out very well. But now we have a couple of great options for us which can really redesign our future roadmap. So that's what Amulya is going to tell you again, that how does the future look like of this framework.
Okay, so yeah, thanks Deepak. Everybody is with me right now. So earlier we started with Chef, machines created with Chef, and the configuration of configuring the software on top of those machines with Chef. So Chef plus Chef. Now then we went to Chef plus Hab, right? Chef still creates the machine, and then Habitat packages comes into the play, and then they configure the software on it. Now let's see where we can take this, right? So where we wanted to take this. So with the rise of popularity of Kubernetes and containers and the options available in the storage for the containers, like vendors like like EBS has this options, and like some other. It is possible that you can run all of this on containers and Kubernetes. So this is where we want to take it, like from Chef plus Chef to Chef plus Hab. We want to take it to like K8 Kubernetes plus Hab. So basically the same interface for the developers. So developers don't have to worry about what we are changing. Same interface every time. Instead of creating virtual machines and volumes, we're going to create containers and attach the storage to it from a storage provider. And then the service which is going to run on the container is going to be configured by Hab. So this is where, and the Kubernetes will be deployed on top of any cloud provider, like basically IaaS, Azure, they all have Kubernetes. You can deploy yourself as well. But that's like, we're not going to go in that detail. So just like instead of VM storage, it's container plus volumes plus the Habitat is going to. So how does this look together, right? So these are the moving pieces. So I mean, like it's a great demo in the keynote yesterday, right? Like how the Habitat operator is going to work in the Kubernetes land, and how the Habitat updater is going to work in the Kubernetes land, and how the builder, the studio, the container, the Docker hub comes together, right? So these were some of the questions we had early on. How this comes together, I think the community and like the Habitat team is answering those questions. You create a, so I can just walk you through like how this things comes together for us. So you start with the studio, Hab Studio, which is your kind of a developer box. You come up with a plan. You build your packages using the builder, and now builder can directly push your packages directly to the Docker hub. So you push your packages, it converts your packages into the container and pushes to the Docker hub. From there, either you can use exporter, Habitat exporter, to export into the Kubernetes format, or you can do it yourself. It's perfectly fine to do it yourself, like do it like with the desired state, and then give it to the Kubernetes, and the Habitat operator will gonna make it run for you on Kubernetes. And whenever you want to push another update, so the new component called Habitat updater can make that update happen. So that's how we think all of these pieces going to come together. One thing to note here is this is early stages of this phase. It's not in production. We do not run this today in production. We're just putting this together, and I think this is how these things can come together, because there's like a lot of things like Habitat, Kubernetes, operator, the whole thing is space is new. So that's how we are trying to solve and aim to solve this problem. That's it from my side. Thank you very much for listening.